This video is about frogs, any member of the Anura order. The Anura include all modern frogs and any fossil species that fit within the Anuran definition. Anura is one of the three groups classified as amphibians, along with the Urodela, the salamanders, and Apoda, the caecilians. The number of known amphibian species is approximately 8,000, of which nearly 90% are frogs. Amphibians are ectothermic tetrapodic oviparous vertebrates. An ectotherm is an organism in which internal physiological sources of heat are relatively small or of quite negligible importance in controlling body temperature. Frogs are broadly classified into three suborders: Archaeobatrachia, Mesobatrachia, and Neobatrachia. As the name suggests, Archaeobatrachia are the most primitive of frogs. These frogs have morphological characteristics which are found mostly in extinct frogs and are absent in most of modern frog species. Mesobatrachia is considered the evolutionary link between the Archaeobatrachia and the Neobatrachia. The families within the Mesobatrachian suborder generally contain morphological features typical of both the other suborders. The Neobatrachia suborder is the most advanced and by far the largest suborder. Its more than 5,000 different species make up over 96% of all living Anurans. These three suborders split into their own superfamilies, containing genus, containing species. With over 5,000 different known frog species, there is a lot of variety to be found. New Guinea's Pedophrene amoensis is not only the world's smallest frog, it is also the smallest amphibian and vertebrate, with a length of just 7.7 millimeters. The largest living frog is 30 centimeters long and is called the Goliath bullfrog, otherwise known as giant slippery frog. A standard frog build can be recognized by these characteristics: no tail in adult form, having long hind legs, elongated ankle bones, webbed toes, no claws, large bulging eyes, and a smooth or warty skin. Frogs have multiple eyelids for extra protection so they can keep their eyes open underwater. The irises come in a range of colors and the pupils in a range of shapes. You might not know this, but frogs have some of the strangest dental plans found in vertebrates. Some have tiny teeth on their upper jaws and the roof of their mouths, while others sport fang-like structures. Some species are completely toothless, and only one frog, the Gastrotheca guntheri, has true teeth on both upper and lower jaws. Frogs have lost teeth over 20 times during their evolution, more than any other vertebrate group. Some frog species re-evolved these teeth after losing them millions of years before. This discovery runs counter to a principle called Dollo's law, which states that physical structures lost during evolution are never regained. An analysis of the other two amphibian groups showed these retained teeth on both upper and lower jaws throughout their evolutionary history. Only 8 other groups of living vertebrates, including seahorses, turtles, birds, and a few mammals, have also evolved toothlessness. There is a tight correlation between the presence or absence of teeth in frogs and their eating habits. Teeth seem to be superfluous for mammals that feed on ants and termites as well. Pangolins and anteaters, which have highly specialized tongue like some frogs, are both toothless. The skin of many frogs contain mild toxic substances called bufotoxins to make them unpalatable to potential predators. Most toads and some frogs have large poison glands, the parotoid glands, located on the sides of their heads, behind the eyes, and other glands elsewhere on their bodies. These glands secrete mucus and a range of toxins that make frogs slippery to hold and distasteful or poisonous. If the noxious effect is immediate, the predator may cease its action and the frog may escape. If the effect develops more slowly, the predator may learn to avoid that species in the future. Poisonous frogs tend to advertise their toxicity with bright colors, an adaptive strategy known as aposematism. An example of this are the poison dart frogs, an especially toxic species. Some natives of South America even extract poison from these frogs to apply to their weapons for hunting, although few species are toxic enough to be used for this purpose. Some frogs that cannot synthesize the alkaloids themselves obtain poisons from the ants and other arthropods they eat. The chemicals involved may be irritants, hallucinogens, convulsants, nerve poisons, or vasoconstrictors. Many predators of frogs have become adapted to tolerate high levels of these poisons, but other creatures, including humans who handle the frogs, may be severely affected. Some frogs use bluff or deception. An example is the European common toad, Bufo bufo. It adopts a characteristic stance when attacked, inflating its body and standing with its hindquarters raised and its head lowered. Another tactic used by some frogs is to scream, the sudden loud noise tending to startle the predator. The call or croak of a frog is unique to its species. With most frogs, the sound is amplified by one or more vocal sacs. Some frog calls are so loud that they can be heard up to a mile away. The main reason for calling is to allow male frogs to attract a mate. Females of many frog species reply to the male calls, which acts to reinforce reproductive activity in a breeding colony. Female frogs prefer males that produce sounds of greater intensity and lower frequency, attributes that stand out in a crowd. A different call is emitted by a male frog or unreceptive female when mounted by another male. Many species also have a territorial call that is used to drive away other males. All of these calls are emitted with the mouth of the frog closed. A distress call, emitted by some frogs when they are in danger, is produced with the mouth open, resulting in a higher pitched call. It is typically used when the frog has been grabbed by a predator and may serve to distract or disorient the attacker so that it releases the frog. Frogs can be sexually dysmorphic. Although there are exceptions to the rule, female frogs are generally bigger and heavier than males. This makes sense as females are the ones responsible for holding the eggs. Other examples include slight differences on their hands and feet, different skin textures, arm size difference, and different brightness of color. Frogs are generally recognized as exceptional jumpers and, relative to their size, the best jumpers of all vertebrates. An example is the striped rocket frog, Littoria nasuta. It can leap over 2 meters, a distance that is more than 50 times its body length. But there are tremendous differences between species in jumping capability. Some frogs have less muscled back legs and prefer walking, running, and small hops. Other frogs have a lot of webbing between their toes so they can swim really well. Members of the family Pipidae are even wholly aquatic. Some frogs have become adapted for burrowing and a life underground. They tend to have round bodies, short limbs, small heads with bulging eyes, and hind feet adapted for excavation. An extreme example is the Indian purple frog, also called the pig-nosed frog. It spends most of its life underground and surfaces only during the monsoon for a period of 2 weeks for mating. Unlike many other species of burrowing frogs that emerge and feed above the ground, this species has been found to forage underground. Quite the opposite of burrowing frogs are climbing and arboreal frogs. Arboreal means living in trees. These long legs and toes with adhesive pads on the tips belong to the tree frog, a very acrobatic frog that can catch insects while hanging by one toe from a twig. The true tree frogs belong to the family Hylidae, but members of other frog families have independently adopted an arboreal habit, a case of convergent evolution. Convergent evolution is the independent evolution of similar features in species of different periods or epochs in time. These include the glass frogs, the bush frogs, some of the narrow-mouthed frogs, and the shrub frogs. During the evolutionary history of frogs, several different groups have independently taken to the air. Some frogs in the tropical rainforest are specially adapted for gliding from tree to tree or parachuting to the forest floor. Typical of them is Wallace's flying frog. It can alter its direction of travel and navigate distances of up to 15 meters between trees. Frogs that live in extreme conditions can enter a state of torpor, dormancy. In colder regions, many species of frog hibernate in winter. Those that live on land dig a burrow and make a hibernaculum in which to lie dormant. Others, less proficient at digging, find a crevice or bury themselves in dead leaves. Aquatic species normally sink to the bottom of the pond where they lie, semi-immersed in mud, but still able to access the oxygen dissolved in the water. Their metabolism slows down and they live on their energy reserves. Some frogs can even survive being frozen. Ice crystals form under the skin and in the body cavity, but the essential organs are protected from freezing by a high concentration of glucose. An apparently lifeless frozen frog can resume respiration and its heartbeat when conditions warm up. At the other extreme, some frogs estivate. This is summer hibernation. The striped burrowing frog burrows underground and curls up inside a protective cocoon formed by its shed skin. If you want to find out more about frogs and other animals, you can follow me on this channel.